anybody wants to join that effort or come up with ideas and solutions. Anyways, I'm going to introduce Wayne so you don't kill any more time. And he's someone, you have all the material on him, which we sent out, and I think he'll explain a little bit of his background and get down to business. Thanks a lot, Wayne.
No problem. All the material, what did you get out of
Well, the invitation gave you
yes,
that.
Okay. I appreciate the introduction. Thank you very much. And I also appreciate the change in the format. I came with a 2-hour presentation. We'll see if this can get into 40 minutes.
No, you make it as long as you want.
Just kidding. No, so anyway, I'm a pretty loose speaker. I don't have a rigid format. I take questions anytime. You're not bothering me. The material is very comfortable for me. I've been talking about the same subject in a different format for some time. Wally here is one of my colleagues I brought with me, because he also is a resident expert on this subject. He's probably doing it longer than anybody I personally worked with, has just a wealth of knowledge and experience. So I brought my lifeline with me. Just wanted you to know that. All right, so appreciate you keeping phones off, pagers off, those things to do to break up the monotony of it all, but do ask the questions. All right, work. There it is. Okay, lowering our energy costs. This is a subject that comes up all the time. People want to know, you know, I'm in the solar industry by background, and people are trying to size up solar systems, and they're trying to figure out how to lower their costs. That's why they want to do solar. They think that's the way to lower costs. And I'm the one that's telling them, sorry, this is the wrong direction. And I have to kind of bust that bubble and back them up a little bit before we go into the solar. And I'm going to get into the details of that and explain why. But it's really understanding the bigger picture of energy and where solar fits into the equation. It's not at the front. It's more on the back end. And you have to understand that perspective. Some considerations here. First one's a Chinese proverb. My wife taught me this. Waste is a resource in the wrong location. Meaning there is no trash. There is no garbage. It's all basically a resource, and it can be used somewhere else. And people look at it and they go, oh, it's trash, it's garbage, and they want to put it in the landfill. There's a better option for us. Number 2, this is from William McDonough, who's done a lot of quotes. But he says, you're asking how much will it cost to build green, when you really should be asking how much it's going to cost to feed on. That's really its own. Because when you understand the big picture of what's going on, and what we can stand to lose if we don't address sustainability in a hurry, it's going to get pretty ugly pretty fast. And the last one is really kind of makes the case. This is from the U.S. Green Building Council's opening. It's that the United States has consumed more resources since 1940 than the rest of the world had since the beginning of recorded time. This rate of consumption is not sustainable. We just can't keep doing this. And it has to change. The limitations are there, we're running out of resources and things are getting expensive. So with all these many options, where do we start? There's a lot of things out there that people are talking about in the green building circles with geothermal, ocean currents, and swell. You guys are familiar with all these different technologies. Wind, biofuels, biomass, algae, solar. I can talk a little bit about each one of these things, but I really want to get to the subject of how we lower energy costs. LED lighting plays in there. Weatherization is a big factor. Public transit is also a big factor. And there's more. I mean, we could sit here and talk about it and probably come up with 20 more items that would add onto this list. It's just, where do we start? Well, in my analysis and studying all these different energy things, I've nailed it down to one item. Where to start? Conservation. Conservation is simply the most cost-effective option we have. There are measurable amounts of wasted energy in almost every building that we build a day. We go in with testing equipment, we find the energy leaks. We locate where that energy is going. And we explain to the client that you've got about a 40% energy loss in your HVAC system. You're losing 20% out your ducts. You're losing energy here. You've got lighting that's really off the charts, and we could drop your loads by 25%, 50%. Sometimes retail stores, I can go in and knock out 80% of their loads by just changing out lights. That's the low-hanging fruit. Reducing wasted energy. costs much less than any other option. It's just simple as that. We can invest in all kinds of things, we can throw our money around, we can make it look good, but it doesn't cost anything to conserve it. And you just can't get a better return on investment. Conservation is something that each individual and business can take a part in. It's every person. It's not something that just for this group or that group. We can all be part of this. And conservation usually means saving costs, putting dollars back in your pocket. There's the mantra, the recycle mantra, the 3 R's, reduce, reuse, and recycle. These are in a sequence and in order for a reason. Because recycling takes energy. Reducing doesn't take any energy. Reusing doesn't take any energy. Recycle takes energy. So it's number 3 on the list. It's important that we keep those in perspective. Because anytime we can reduce how much we're consuming and we can reuse anything, we eliminate that extra step of having to spend more energy to recycle it. So conservation is just at the top of the mark. Energy conservation. This is what's really changed in our industry is the technology. We now have tools that they have developed, like infrared cameras that allow us to see in colors all the energy where it's going. Like blower door tests, so we can pressurize the building in the envelope and find out where the leaks are. Duct testing equipment, combustion safety equipment. The testing equipment goes on, there's Gauss meters, there's just all kinds. You can spend $25,000 in testing equipment now just to test a home. Find out what's going on and where everything's going. And it gets pretty complicated and sophisticated to understand all of it. It is a science. The Building Performance Institute has been working on this for some years, and they have got it down to a T. I would say this because I've noticed a lot of the green building circles, including LEED, is paying attention to this. Everybody's pushing now for more commissioning versus prescriptive. It used to be prescriptive was the way to go. They give us a list of things, if you do this, and this is how you're going to get to your mark. And they would award you with a nice plaque and tell you got this nice certificate. But did it really get us where we wanted to get to? We're finding out that a lot of these LEED homes didn't meet the mark when we tested them. That was surprising. I mean, LEED platinum homes that were failing in the energy section. It's really kind of got some people's attention. And they realized the need for change. So now, in the new rollout of LEED for 2012, if anybody's up on LEED, you're going to see where they're requiring more commissioning, more testing, verification to prove that you're actually saving energy, not just a prescriptive list and you do this and you get your points. They want to come on the back side and verify it. Energy analysis. This is the list of the things I just kind of went through. Visual inspection is the number 1. With an experienced eye, I can go through a building inside and out, and I can, without using any testing equipment, I can usually find 20, 30 things, and they start pointing out, this has got to be fixed, that's got to be fixed, there's a leak right there. And it's not that hard to do that part, but that doesn't give us hard numbers. Blower doors give us hard numbers. We know exactly how much leakage there is in a building. Duct testing gives us hard numbers. We're finding we can save sometimes as much as 30% on their total energy cost just by fixing the ducts alone.
What do you mean by fixing?
The ducts, you go up with the thermal imaging camera up in the attic, it's 140 degrees, you point the thermal imaging camera down the ducts and it's blowing cold air through there, and you see all these blue streams flowing out here and there. It's just all the leaks in the ductwork. Ductwork represents about 40% of the air and the total air within a building.
So it's not the position of the louvers. It's
Well, that's another factor, and it's a good point to bring up. But the duct itself, those tubes that channel the air, are big culprits for leakage. And when you find that 30% of the air is leaking out into the attic at 140 degree temperature, your HVAC is working overtime.
Yeah.
It's just, and that's a big culprit. Without the testing equipment, it's really hard to, you go up there with your hand and go, I think I feel a leak here. That doesn't work that well. So, it's the testing equipment. I own one of these thermal imaging cameras, about $6 grand. It does a phenomenal job. I can see things, and I can choose whether I want to see them in what they call rainbow, which is a whole range of colors, or I can see it in iron, which is more technical, grade scale, and it helps me to see things. But when I'm talking to clients, I'll put it back in rainbow with all the colors. They like to see all that, and it helps them to see what we're talking about. But mainly, it's eliminating the guesswork. For many years, weatherization has been going on, where they go in and they go, oh, we can save some energy bills. We'll put some sealing on the doors and the windows we'll find out where the, your other lease yard, we'll fix those, we'll caulk them up. And you've probably heard about it. It was a Cash for Caulkers program. Okay? What they found was that they were actually decreasing the quality of the air within these buildings without understanding what they were doing. Buildings have a stack effect. They basically have low pressure at the bottom, they have neutral barriers at the center, and then they exhaust air at the top. Well, what happens when you seal up those neutral barriers at the center? You just increase the leakage from the bottom and the top. The two areas we don't want to get leakage from are crawl spaces and our attics, which is usually contaminated with all kinds of wonderful debris. If you crawl around an attic, you're probably familiar with this. There have been cases where people have gotten weatherization of low-income housing, and all of a sudden their kids are got respiratory problems and illnesses, and they're at the doctors and trying to figure out what's going on. What they did was they basically infected their home without knowing what they were doing. They were with good intent, trying to save some money on energy, but didn't understand the science of the building. So that it's really important to really have a full perspective of what you're doing when you go in there to start changing things in the envelope, doors and windows. And you realize that if the doors and windows are at the neutral boundary, they're probably not the biggest culprits for leakage. It's the floor and the attic. It's where we lose most of our energy. And so if we find that if we seal up the floor and the attic, a lot of times we don't even need to mess with the windows. They can be single glazed windows in an old Victorian home from 1900, and we can get to the energy efficiency that we want to get to. But you ask the window guy who's selling windows, oh yeah, we got to get rid of those single glazed windows, man. Yeah, let's get those things upgraded to triple pane. And and then you get the windows and you go, well, where's that energy savings I was looking for? And it's because nobody bothered to do these numbers to find out, is it really going to make a difference? When I took the course at BPI, I found out that I can actually test a home and I can tell you how much the windows will save you in energy cost. Well, that's a great number to have, because now you have a return on investment. You know what's going to save you. You know what the windows are going to cost. You can do the simple math and figure out, what's my ROI? Does this make sense? The window industry doesn't want us to do that. It makes it hard to sell windows. Same is true for solar, and I'm a solar guy, and I'm going to basically bust the alarm here on my own industry. It's basically solar is sold all the way down the line from material suppliers, the warehouses, and everybody else. They're all incentivizing everybody to sell squares on the roof. How many squares can you get up there? The bigger your commission be, the more sales, the better price you're going to get on those panels. But that doesn't solve the energy problem. And a lot of times they're putting way too much solar up there than they need to be, much more expensively than they need to be. And I'm going to get a little bit further into this.
Can you mention on the blower door, can you describe what that is?
A blower door looks like a fan mounted in a frame, and it has a fabric on it that wraps around the frame. It makes it airtight. The frame expands to fit within the doorway, top, bottom, side to side, and we fit it in there, usually at the front door of the house. And we close up all the other doors and windows and everything else, and we start checking. And with called a manometer, it gives us a reference from outside to inside or from room to room to find out where the pressure boundaries are, what's negative, what's positive, so we can chase down the leakage. Then we go around, once we depressurize or pressurize the house, that's two different philosophies, which one's the better, but we go around with what's called theatrical fog, and just kind of hold it up to the electrical outlets and windows and watch the fog. It's sucked right outside. It's, because we're creating a positive pressure zone inside that's negative outside. It'll just pull the fog right after. You can just watch it go out. Or vice versa, we can create a negative pressure inside and we have somebody walk around outside with the fog and watch it come sucking back inside the house. And that visual really gets people, excited about their home, like, oh my gosh, we gotta fix that. It's because they can see it now. The testing equipment has made it so it's just plain and obvious. That there's no mystery about it. Everybody sees it. They know I'm not making it up and I'm not just giving them a bunch of phony numbers.
I was wondering how you quantified it. So you're basically, whether you're measuring pressure or flow, you're basically measuring pressure drops at different locations.
Yep, and that's, I can tell you're up on the pressure flow at the pascals. Pascals is Pascal is a unit of pressure that's equivalent to what we refer to as a gnat fart. pardon the expression. It's about that much pressure. And they measure in 50 pascals of pressure. They pressurize the home to that effect. And then we go around and we measure where it's all going. And it can be very alarming.
How much leakage are you getting out of your electrical outlets and bathroom fan exhaust?
It all depends on how good the job they did, because if you put an electrical outlet in properly, you're going to, after you get the box set in place, you're going to spray foam all around it.
You are.
If you're doing it properly. But typically, you can pull off the face cover and look right inside the drywall and just see the gaps.
Only if you live in Wisconsin.
Right? And this is what typically happens. Nobody's bothering they'll punch holes in the wall and they'll put a little plastic cover over it and call it good. That doesn't stop anything.
So when you do this analysis,
Mhm.
what sort of differentiation do you say, okay, this is acceptable, this isn't? Where do you draw the line?
We want 0.35 air changes per hour. It is a good reference of quality airflow that we get.
How did that number get derived?
BPI did a lot of testing, numbers, and realized that they needed to change a specific amount of air to keep fresh air in the building. A lot of HVAC systems are closed systems. They don't bring any fresh air in. It's just a loop. It's going through the building and it's never getting any fresh air. And they're finding that's poor quality air. They now are requiring that you've got to supplement fresh air into that. And we're looking for, like I said, 0.35 or 1/3 of the volume of air in this room every hour.
BPI is.
Building Performance Institute.
So if you go into a building and you see that it's much higher than that, say, okay, I want to bring that down. And you rarely probably see lower than that though, right?
Oh, yeah, we do.
So you open it up?
Yeah, in fact, the mantra is, the ultimate goal is to seal it 100% tight and then mechanically ventilate it right. Because you can control mechanical ventilation.
Sure.
I mean, I can go and seal a hole up 100% and there's hardly any leakage. And then you put a little bathroom fan in there with a filter on it, cost you $1, $1.50 a month to run, and you control the quality of fresh air coming into the home. But it's understanding that balance and making sure you got the right flow and everything else. You mentioned ductwork, the louvers, the register sizes. The supply register is, there's a supply and a return. Supplies bring air into the room, returns take the air back out the system. We're finding that a lot of the return air ducts are undersized. There's a manual J calculation that HVAC guys are required to do to figure out what size all these things are supposed to be for the volume of room that they're going into. And we're constantly finding them undersized, just not getting enough return air. Well, this chokes the system down and it doesn't perform properly. I'm going to jump ahead here because the CPUC, this is the California Public Utilities Commission, had gone out and tested 500 HVAC systems. And out of 500 HVAC systems, they tested them in 5 categories. One of them was the registered duct sizing. One of them was duct leakage. One was compressor sizing. Making sure you get the right amount of tons of cooling and heating in the building. The filters that they use on them, what the grade of the filters were, and I'm trying to remember what that other, that's the combustion safety aspect, but they tested them. The interesting thing is out of 500 systems, all 500 failed in at least 2 out of 5 categories. And we didn't have one HVAC system that passed in all 5. And that's the state of our industry. Another interesting fact that says right here, 97% of HVAC systems sold are never inspected. How do they know this? Because they go to the county and see how many inspections were pulled for an HVAC system, and they go and find out how many were sold this year. 97% never get inspected. Why? Because the HVAC guy goes, you don't want to pay that extra money. I could do this. Great. He goes and installs it, nobody inspects it. So how do we know it's working? I did a home in
So there's no requirement to inspect?
well, if you
Like there
ask
is
the
for other building
city,
inspections?
sure, the city will tell you need a permit. But do you think if I go up in your attic and I put a HVAC system in there, anybody's going to really know from the city?
Yeah, unless you've got an angry neighbor that reports you, or you self-report yourself.
I would think new construction to get the
Oh,
building
new
permit.
Well, new construction,
Yeah.
but 97% of these are not going, they're going to retrofit, most of them are going to retrofit old HVAC systems, replacements. yes, new construction is a percentage of it, but the majority of HVAC systems are not going to new construction. They're replacing older, outdated systems.
New business plan.
Yep.
How about if you had a home where you sold it, and then you have part of the home being sold like through escrows, having it inspected, wouldn't that come up?
That would be great if the inspectors had the testing equipment I have, and they did that. But if you know one home inspector that has a blower door test or a duct testing equipment, they don't test that.
You know, I'd say too, as both an architect and a home builder, and I don't mean to be too harsh, because there are notable exceptions to this rule, but most home inspectors are unemployed carpenters, and if you have ever read their report with all the disclaimers, they want to get in and out of your house, charge you $300. They'll occasionally burn a homeowner and move on to another set of realtors that refer them. And I know I'm being a little harsh when I say that, because I know some incredibly unique exceptions to that rule. Men and women that are brilliant and take the job seriously, but sadly enough, they are the exception to the rule. Yeah, there's one out of Ojai. I don't know if you know Tom Colton, speaking of this
I know
issue.
Tom.
He will inspect every piece of equipment in the house, go to the county, and pull permits for the last 20 years. And if you're the buyer, he'll tell you when a light was illegally installed in the laundry room in 1958. The guy's awesome. But again, sadly enough, he's a unique exception to the rule for home inspectors.
And they don't even need to be licensed,
Oh,
correct?
no,
Right?
no, anyone can do it.
Yeah, which
Have
is
at
good.
it, yeah. You
Tom,
should have a,
Tom does this for $300?
Yeah.
What was that guy's name?
It is the state of our affairs, but I don't want to pick on the HVAC guys alone. It's not just them, and it's not really their fault. They didn't provide the proper training for this. I was just talking to a young guy who used to work for me years ago as a carpenter. He got in the HVAC industry through another contractor and worked for him for 4 or 5 years. And went out and got his license, and he ran into me and goes, "Yeah, I'm now a licensed contractor and I'm doing HVAC work." And I went, "Oh, that's great." And I go, "How are you doing your manual J calculations?" And he went, "What?" It was like a deer in headlights. He didn't know what a manual J was, and I was like, "Oh, this is scary." You know, because that is how you determine the sizing of the compressor, the equipment, and everything else, is doing the math to figure out what it takes. We did a house in Orange County, Anaheim, and elderly lady living there by herself, a little 1,200 square foot home. She'd been living, her husband had passed away the year before, but when in the interview, we asked her, you know, how cold, is it hot, do you have drafty spots? No, she's comfortable, house is fine. But she was inspired to check out the energy audit, and we went out and we did this, checked her whole house out. She had a 7-month-old trade air conditioning system, fairly new, in the air, up in the attic, 3 tons, put in the house. And we suspected 3 tons was a little big for this little 1,200 square foot.
Square foot house, 3 tons is a lot.
We got in there and we found out that she had over 50% duct leakage. So this means 1.5 tons of the energy is actually going in the home. The other 1.5 tons is going out to the roll. And she's comfortable. So what do we know? 1.5 tons would have done the job. She got sold twice the amount of compressor that she needed to be buying. Twice as big an air conditioner. That's the state of our industry. I'm going to shift from HVAC guys for a second, go to the insulation industry. The insulation industry is just as bad when it comes to testing and verification. Having insulation installed properly is a challenge, and I've had long discussions about this, and I can actually speak from experience, because when I was a young man fresh out of the Navy Seabees, I got a job here in Camarillo with a punch pole and a utility knife stuffing insulation, and there was no training. They pointed to the bags and they gave me a utility knife and a punch bowl and said, "Get $1 a bag, go to it." And we were cramming that stuff everywhere we could. That tub, I'm sticking it in there, man. I got to get some bags, you know, and go back and turn all my bags in at the end of the day. So we're hustling to get these things in. Do you think we put it in right? No, not at all. In fact, this is what I learned in BPI many years later and had to think, oh my God, I was doing it wrong.
Wayne was wrapping the family golden retriever around and duct taping it.
Yeah, we figure out a place to put it, yeah, those,
Keep you cool,
those
too.
voids in the framing in the little pockets, hey, I can get insulation there, man, this works. But really, what we found is that insulation is supposed to hit all 6 surfaces. So if you think about a stud bay, the insulation should hit both studs. It should hit the top, it should hit the bottom, it should come to the drywall, and it should go to the outside. If there's a gap anywhere, a 1/4 inch represents a 40% energy loss in that bay. A 1/4 inch. 40% energy loss. Now, here's the real alarming part. We think insulation, we're gonna make our house warm. Insulation doesn't work by itself. I'm gonna give you an analogy of a jacket. We're all familiar with fleece. Fleece is like insulation. It'll keep you warm, but if there's a nice strong breeze outside, it's gonna cut right through that fleece, and you feel the leakage. So what we need is that outer shell, the windbreaker on the outside of the fleece to cut the wind, but you still need the fleece for the insulation because that windbreaker by itself won't keep you warm. Same thing with our homes. We need air sealing in place with the insulation. If you don't have both, you got a problem. And that's where the problem is. The majority is the air leakage. And the insulation industry by itself doesn't stop it. Unless you pay for the more expensive insulations like the spray foam. The spray foam not only insulates, but it gives you air sealing at the same time. Cellulose gives you pretty good air sealing as compared to batt insulation, the fiberglass. Air goes right through that stuff real easily. So getting the right air sealing in place with that, in the plane, getting that seal and then doing it properly. I've seen it done improperly, where they put the air seal on the interior wall, the insulation, and they had Tyvek material on the outside wall. All of a sudden they created this big moisture trap in the wall cavity. It didn't breathe right, and then we had the mold starting to grow and more problems. So again, you can have all the right pieces, you can go in there with good intent, but if you don't know what you're doing, you can mess things up. So it is a science. And it really got my attention when I took the courses through BPI and realized how much I didn't know about building homes. I've been doing this my whole life. Skipped over some numbers here. 42% of all the energy in California was for heating and cooling of homes. This is from the CPUC. This is an important number. That means all of our energy, 42% represents the heating and cooling of homes.
Including transportation?
When I'm talking about the energy, we're talking about the electricity and the gas that's consumed in the state, natural gas. So no, I'm not talking about transportation, unless it's electric rail, which I don't think we have any. Should, but we don't. And along with that number, that energy retrofitting, this whole process of retrofitting a home, testing it, and fixing these leaks and everything else, was saving 40 to 70% on average. These are strong numbers, and I'm going to come back to these numbers later in my presentation because I want you to get a perspective of what this really means to us. But the numbers are large, 40 to 70%, meaning we can save roughly half of the energy on any given home by just going and retrofitting. Well, what do you think that means to the solar industry when we're sizing up the solar system? That means if you're sizing up solar for the total energy usage, you probably sold them twice as much as they needed.
I can support your value. I have a solar company.
Oh.
And we target commercial and industrial buildings. And so what we do is we come in and do exactly what you're saying. Probably not to the nth degree you are because we don't have that much time, but we realize that our competition is going to say, hey, give me your utility bill. I'm going to slap a solar system on your roof to match your utility bill. Where we come in as a value proposition, a holistic view, we want to reduce your energy uses, make you holistic, the lighting, the HVAC, all the things you're talking about, right? And so then instead of spending a $500,000 system to match your existing usage, now we come in as a competitive advantage. We only need a $300,000 system for solar. We just saved you $200,000, made you more efficient, etc.
And the money you spent to get there was nowhere near what it would cost you to do that solar.
Exactly.
The return on investment on this is much better than solar. That's the bottom line.
His pitch is our value prop.
Yeah. Let's see, buildings and air sealing, quality insulation and insulation, 28% savings just from getting insulation installed properly. 40% savings from doing the air sealing and insulation work together. 30% energy savings typically from duct leakage. Now, don't get too carried away with these numbers. You add them all up, you're gonna go, wait a minute, I can get over 100% savings here. It doesn't really add up. We're talking about averages of homes that we go in and we're testing, and this is what we're finding, that the potential or opportunity for savings is. These are strong numbers. Now, I'm not saying all the homes have all these situations, but we're finding parts of this in some and other parts in others. And just going in and verifying it, testing it, getting the hard numbers before you start doing any work. Eliminate that guesswork. Compressor sizing, I talked about bigger is not better. Well, I mentioned that they're being oversold, but here's what happens when you put too big a compressor in a system. They short cycle, meaning they get up to temperature and then they shut down. And then they ramp back up and they get back down because they're so oversized, they get to temperature real quickly and then they shut down, and then all of a sudden all the temperature goes away and then they ramp back up. If you undersize a compressor, in contrast, slightly smaller than what you need, it'll run constantly. Maybe take longer to get to that point, but it'll use a whole lot less energy getting there because it's not short cycling. It's ramping up and shutting down, ramping up, shutting down, and it'll be a lot more comfortable and consistent within the building.
So how does that fit in with putting the thermostat up? For instance, I keep my thermostat at around 84 in the summer, so it cycles. So should I keep it down around 68? Or?
Well, in my perspective, thermostat should be set so that you're cooling your house and keeping it at a constant. You don't want to try. It's really hard to take a home to all the way down and then bring it to temperature. If you hold a constant, that uses less energy than trying to go through the patterns, if you will. It's also a lot of upkeep to try to stay on top of that thermostat all day. But we find that buildings use less energy if they just keep a nice constant and not be changing the thermostat throughout the day.
So is it better to keep it cooler during the summer?
Well, you want to find a happy medium. We like to see thermostats set in the summertime. We like to see them set about 75, 70, somewhere in there. I mean, 80s. If you can live with 80, that's great. 78 is a good number.
I think the question for if I'm in my office all day long, no one's in my home, my kids are at school, my wife's out and work, whatever she's doing. There's someone in my home from 8:30 a.m. to 5:30 p.m. Let's put the HVAC off, have it go on at 5 o'clock before we get home.
I'd have to really, to find out, I'd have to test the house to really know. Because I don't know what your house is. I don't know how leaky your house is, how long it takes for the system to cycle. I'd really have to get in there and test it to answer that question properly. Yeah. But typically, if you just keep the house constant and you don't have air leakage, you're not going to be using that much energy. I'm going to get into some other factors here. I'm going to show you, when I show you what Europe's doing, it'll make this look ridiculous.
But it sounds like, Wayne, is that when you talk about this 100%, what you're really talking about is, in essence, turning your house into a thermos bottle. And so that, yes, you're setting your temperature at 70 degrees or 75. And so the house gets to that temperature, the equipment cycles off, but it may stay at that temperature for hours before it has to cycle back on again because you're losing or gaining temperature so slowly because you're a thermos bottle.
Yep.
Okay.
If you have the air leakage, you don't have the thermos bottle.
Right.
And that
it's like it's a thermos bottle with the top off.
Right. Yep. Or it's what I typically say, the teenagers left the bedroom windows open and they've got the HVAC system running, and they're wondering, how come my electric bill's so high? And I see this all the time. I'm going through doing audits and I go, okay, you got all the doors, windows buttoned up, I'm coming out with my thermoelectric camera, oh yeah, it's all sealed up. I go through the house, I'm like, oh, these windows are open. I'm like, oh yeah, I guess Johnny left the windows open. Happens every day, constantly.
On the HVAC systems, are they doing anything like they're doing on the pool pumps now with variable speed or variable flow to try to help on the energy side?
The newer equipment, VFTs, thank you. The newer equipment, yes, they're coming a long ways because the CPUC is recognizing this is a problem. The industry is recognizing this is a problem, and there are people in the industry that are seeing that, hey, they're testing us now. It's kind of like, all right, we've been exposed, we've got to fix this. And now they're coming out with better technologies, better systems that use a lot less energy.
I think, on the commercial side, all the major manufacturers, plus a bunch of really creative garage shops, are chasing this. Unfortunately, on the residential side at the moment, there's limited activity in this, and I can understand that as a guy in the, residential industry. The major residential manufacturers, the residential component of an organization like Train, at least in this economy, they're chasing low bid that's code legal, and it's just the reality of them surviving. And I think when the market ramps back up, you're gonna see a lot more on the residential side, but unfortunately, pretty dormant at the moment.
I'm gonna just touch on a couple things real quick here and jump this next slide. HEPA filters, MERV 13, antimicrobial. These are all new, finer filters for getting more particles out and getting better air quality. However, when the homeowner goes out and buys these filters and puts it onto their existing system that wasn't designed for that kind of filter, they just choked it down. It restricted the airflow. It's just like putting a smaller return air duct on it. So you have to keep the science there. If you want to go to these filters, they're great, but have the system designed for that filter so that you're getting the proper airflow. And then you maintain the quality. So again, it's a science. It's just not, you don't just go buy the filter as a patch and stick it on there and think, I'm good. It doesn't work that way.
Unless it has the same SCFM rating.
Yeah, this is cubic feet per minute. It allows the square cubic feet per minute to go through there and keep the flow going. They do make some filters. I question how well that works personally. If it allows the same airflow, I wonder how much leakage there is. Yeah. Framing techniques on new construction have come a long ways in the sense of making it easier for us to insulate properly. The old framing techniques created a lot of what we call hollow corners and channels and chases throughout the building. We're getting better. The industry is changing because they're recognizing that this is an issue, and so it's coming right down to the carpenter who builds a house has to make it in light of better insulation, better air sealing. Lighting and appliances, of course, those are pretty straightforward. You go through and you just do your calculations, loads, figure out that a 10-year-old refrigerator is using 3 times as much energy. That's low-hanging fruit. Let's get that thing updated and changed. All right, show me the money. Wally and I did a presentation earlier this year for contractors, and we got into the depths of this. And I'm just touching on a couple of things here. Energy Upgrade California. In LA County, you can get up to $8,000 towards fixing your home. It's $4,000 from the energy company and $4,000 from LA, from LADWP.
Wow.
So $8,000. They have the same program for Ventura County, but it's not quite. I think it's $4,000 in Ventura County.
Yeah, but in some of these cities of Ventura County, it's up to $6,000 because cities have individual grant money they're doling out. So yeah, depending on where you are in the county, 4 to 6 grand.
Is it a sharing thing or is it a grant like?
It's a here's the cash, don't give it back grant. Now it's based on a formula of how much total money you spend. So you're not going to get $6,000 in the city of Camarillo for spending $6,000, but you'll get about 50 cents on the dollar. You spend 12 grand, they'll give you a bucket of money with 6 grand in it and say, never pay us back, have a nice day, sir.
Now, on top of that,
That's a
you
pretty
just
good
cut your
deal.
utility
Yeah,
bill.
very
So
cool.
you get money for helping to pay for the cost, plus you're getting reduced utility bills.
Oh, it's double dipping.
Exactly.
Yeah, it is. I mean, if you think of that, as you've also done it, and this is the case with a lot of homeowners,
Yes,
and my utility bills are now $75 less a month. That's like me also coming to you and going, hey, why don't I knock 10 grand off your mortgage too? When it comes to, I mean, seriously, when you do the math, it really is. And that's pretty darn cool that,
So that's for existing homes. For new homes, California Advanced Homes Program through Edison, they have money that they will bring to the table if you're building a new home, if you're willing to work with them in their design and agree to their change, the recommendations that they make. This means coming in early with your architect, your design, before you start building and sitting down with Edison and going through the design, and allowing them to make suggestions and changes, and you can get money to help build your project.
Is one exclusive of the other?
Yeah,
Can
then
you
one,
use the second
yeah,
one?
the first one is for
existing
existing homes, the second one is for new construction.
Right, but after you built the home, now it's not new anymore, can you go after the other one?
That's a good question.
Well, but if
I have not had that question before.
That's a
I don't
great
honestly
question.
know
Are
that
you
one.
an attorney, sir? With all due respect.
If you stumped him, man, that's good.
Well,
That's
in
a-
theory, the audit, if you audited a new home that went through that, it shouldn't have such big savings that you would
Yeah.
actually get a
Yeah,
check.
if you did California Enhanced Homes, it's really unlikely, because what Wally didn't mention that not only will they give you half the money, but you also have to hit specific marks in the energy. What I mean is test in and test out. They come in and start, they test, they get a baseline set of numbers with this test equipment, figure out where you're at. They do the retrofit work, and they come back in and they test out, and they find out what's the difference. And if you hit 10%, they will give you about 25% of the money. If you hit 40%, they're more likely to give you all the money. If you come in anywhere between, they're gonna give you a percentage of the money. So it's not a straight formula. You have to actually prove that you saved this much energy from your usage.
So you, the homeowner, and you, the contractor.
Well,
Right, the contractor has
it's
to
the
do a good
homeowner.
job.
The contractor's doing the work, but it's the homeowner who's the one who's gonna basically reap the benefits of all this or lose out if it's not done right.
I've heard some contractors are tying their, are doing incentives for themselves, basically. So if they get the homeowner to the highest percentage, then they'll get a bonus, or they'll get a.
Some contractors sell it that way.
Yeah.
Some of them do.
Yeah.
They basically build in their own incentives. If I hit this mark for you, then I want to get this much money. You know, it's a way of packaging it. I know a guy in Northern California, Rick Chitwood, who basically gives them a bill guarantee. Your utility bill will not exceed this much per month once I'm done.
You know, something else.
He's willing to pay the difference if he fails.
You know, something else not to be lost, because we have a bunch of business people and entrepreneur here, is Wayne's talking a lot about incentives on the home side. Edison has some amazing programs on the commercial side, and I say by way of example, yeah, there you go, and I'll let them talk about it. I just banged Edison for 30 grand for an existing building an owner uses. It's a large mini warehouse in Oxnard. The owner's gonna spend about $50,000 in upgrades. Edison's giving him 30 of it, and he will save that 20 in under a year. I mean, is that amazing or what?
It's a no-brainer.
You know, give me 20 grand, we're gonna do some work, you'll get the 20 grand back in a year, and your utility bills will be 20 grand a year less forever. Pretty good ROI. Doing better than my retirement program.
So, go through this pretty quickly. Savings by design. All this is commercial now. Savings by design. Again, going to the table with Edison with your project, letting them coach you on how to build your project. They will bring money to the table. PACE financing. This is they will do not only energy efficiency retrofits, but solar also. And this is for commercial programs. It's the Property Assessed Clean Energy Program. And what I mean by property assessed, they're doing the values, they're doing the caps. How much money are you going to save if you do this energy retrofit? Or in other words, how much increased spending will you get out of this? There's another similar program in the residential section called EEMs, Energy Efficiency Mortgages. This is where the bank is going through and they're seeing the numbers that we're showing them how much you're going to save on your utility bill. They'll increase your loan based on that increased amount of spending money that you're going to have. So the banks are getting pretty creative. The last one here is one of my favorites. This is a recent program from one of the banks. Guarantee me if I've got a user of 3,000 gallons or more per day of water, commercial, that they will finance the solar heating for that water at 75% of their current cost. That's a guaranteed 25% savings.
Who's doing that? Sorry.
A bank.
A bank.
Colleague. I'll tell you about it. But that's one of my point is that the lending institutions are starting to step up to the plate. They're seeing how the energy savings is playing into the cash flow. They're creating these programs to make the money work.
As of recent?
Oh yeah, this is
Very recent.
Very
Yeah,
recent.
I'm working with both.
You can't get money for anything from.
You know, I'm working with both Bank of America and One West right now as a consultant. We're trying to figure out how to get better at this exact thing, because they haven't done enough of them and they don't have enough metrics in to see if it's making sense for them. And I'm respectful of all new.
Inside the home. I was talking to some of you earlier about the biobiology things that we've learned.
The video ran out.
The EMFs, the EMRs, from the electrical currents going through our homes and how that's affecting our health, the air quality, how that's affecting our health, the VOC contents, the materials we're using, and all these things have a factor on health. And health is something that's hard to put a price on, because if you don't have health, nothing else is important. See, we are creating environments. I do this with the kids at school, by the way. I tell them about an aquarium, because they can't relate to this whole building science. This is just over their head. But I talk about an aquarium with fish in it, and there's water, and there's air being pumped in there. They get this. They understand it. They go, the air's got dirty, what happens? Fish die. And they all tell me about the fish they had to flush down the toilet. And if the water gets dirty, fish die. If there's too many fish in there, it gets crowded, the fish die. So, you know, they go home and go, I don't want to be a dead fish. Parents get it, you know, and then go home and teach it to parents. So that's a great teaching acronym, that the world is our aquarium. We're creating environments. Our homes are our living environment, and they need to be in light of the health that we're living in. So appreciate the question. Renewable energy. I love renewable energy. It's great stuff. But it all has its pros and cons. I'm just going to jump through this real quick. Wind power, it's all about location, location, location. In the right location, it's a great thing. But in LA County, what the Indians used to call the Valley of Smoke, because it never went anywhere, it's not a really good application. Interesting enough, we built a big city right there where they found out that the smoke didn't go anywhere. Geothermal. This is one of my favorites. If you guys know about Lake County, California, cleanest air quality in the United States. And all of their power comes from geothermal. This is pouring water down a pipe into a geyser. It turns into steam, comes up the other pipe, and turns a turbine. There's zero emissions. They get all their power from it. And there's hot springs all over the place. There's hot spots all over the place.
They have the largest geothermal plant in the world in Lake County.
Where is
It's kind of rural. It's about 60 miles north of Napa, Sonoma.
Okay.
So a little northeast. If you went over the hill, you'd be in Humboldt County, kind of Eureka, the far northern coast. So yeah, north of Napa, the other side of the ridge from
Wine
Humboldt.
going up and wine coming back. I love it.
Exactly. Exactly. Yeah. It's a,
So we just need a volcano here in LA County, isn't it?
We got more up
We have La Brea Hot Springs.
right.
Yeah, right.
Yeah.
Biomass, great potential energy. Camarillo's building a facility to make gasoline for cars from biomass. This is from trash. Gill's Onions in Oxnard used to throw away all your onion skins. It was just a waste product. Now they're using them to make a portion of their energy on site. Biomass, this is a great option. Algae, I want to just go through this real quick here. This is a great story. I learned this from a retired United States Navy submarine commander. He went before Congress in 1999, and he explained to Congress, and I got this report by the way, how if they took 6% of the Sonora Desert, which straddles over Arizona, Mexico border, 6% of the desert, they could produce with just algae enough fuel to get Mexico and the U.S. off of foreign oil in 7 years. That was 1999. You think they did that?
No.
No. And he's still fighting that battle to this day. Still trying to petition.
He'll be dead before he ends that battle.
But it was a great analogy because algae doesn't take fresh water like so many of the other biofuels do. It doesn't compete with food crops. It doesn't need farmland because it'll grow in the desert. It'll use salt water, or brackish water, dirty, polluted water. It grows on anything, and it's about 50% oil by content. Yes.
Well, people think of the oil companies as going out and finding oil and digging it up out of the ground. But what really you have to think about oil companies is they're in the shipping business. They ship oil from A to B, and they don't care where it came from, and they don't care who found it. They're basically in the import-export business.
You're absolutely right. And people ask me all the time, they go, wait, all this information, we can put the oil companies on business. I go, no,
Yeah.
they're just going to shift gears. Where the industry goes, that's where they'll be. They're already selling solar panels.
Mm-hmm.
You know, BP is not just British Petroleum; they're also beyond petroleum. Don't know if you know.
Good marketing.
let's see, freshwater, seaweed, pond scum, and Salton Sea. The Salton Sea is an interesting one. The Salton Sea has the dirtiest river in the United States coming into it, called the New River out of Mexico. Really dirty river. If they grew algae in there, they could do a couple of things. They could make fuel. They could turn the Salton Sea into a resource. It would grow in that nice salty water, no problem, but it would clean the New River. And this has been done. The Potomac River back in D.C. used to be one of the dirtiest rivers we have, and today has more fish in it than we've ever seen before. And it was through planting a series of plants in the Potomac River that cleaned up the toxins naturally. It got to be so out of control that they now have lawnmowers, if you will, that they float down the river just to cut the plants back, to keep it all under control. But the water's cleaner. And I mean, coming out of all those cities and everything else, population didn't get any smaller, but the water's cleaner. So that shows us that we can make improvements, we can get a handle on this thing.
You wanna know what's ironic about that last statement? They're building a 750 megawatt solar farm at the Salton Sea.
Yeah.
AES is putting it up.
Right, right.
Where are they in the approval process on that, speaking of this lifetime?
Oh, it'll be commissioned 2013.
Oh, cool, so it's under construction.
I want to mention one last one, seaweed. Seaweed is algae, and we all have probably seen kelp growing out there in the ocean. Kelp grows 15 to 19 inches a day. So picture this, you can take a barge floated across
Fastest growing plant in the world.
Yep. You can go take a barge floated across the kelp, cut 8 feet, 96 inches, once a week, and never run out of fuel. It's a never-ending source. It just keeps growing back and replenishing itself. And you wouldn't hurt the ecosystem, because whenever you go float anything over the kelp, I know from fishing, critters go down to the bottom. So you can go right across the top and cut the 8 feet off, you're not going to hurt anybody's ecosystem. In fact, you're going to cause it to grow and replenish more. So that's another potential resource for us that's right there in front of us everywhere in the world. Solar. Now, I've been bad-mouthing solar all this time. I thought I should come back from the other side of it. Kind of give you I don't hate solar. I think solar is good. I work in the solar industry. And I think it can really have its place, but you have to keep the perspectives. Energy efficiency is the most affordable path to renewable energy. If we address the low-hanging fruit and get rid of the wasted energy first, we can make affordable solar systems. It should be required, meaning you should be required to hit an energy audit and hit a certain mark before we start giving out the people's money and incentives to help you buy the solar system. Because currently, what are we doing? We're incentivizing the wealthy to buy solar. That's the model we have now.
But they're also creating a critical mass. I think all the supply and demand, they're creating a critical mass to get the prices to come down. That's one argument, you know.
The marijuana industry would tell you the same thing from the 70s, that they were the critical mass that drove the solar industry. 94% of the capital venture in the 70s for the solar industry. The Zenergy House. This is Studio City. You can Google this. Zenergy House is a house that was 2,500 square feet. Ron and Tammy Schwalski bought this house, went through and did the whole energy efficiency retrofit from top to bottom. Changed out the FAU to a hydronic FAU. That's a whole other conversation how this works. But basically using hot water to do all their heating and cooling, not gas. And very, very efficient. More importantly, they went through this whole house, and at the very end, the last guy they called in was me. Said, Wayne, we're there. Now we need to get it to 0. And I came in and did the calcs, and I was able to put a little 2.3 kilowatt system on the roof and got to 0. Their gross cost, $17,000 after incentives, less than 10 grand. If we get solar under $10,000 per home, solar will go mainstream across the U.S. because everybody can afford it. But when we're selling $40,000, $50,000, $60,000 systems to the average homeowner, it's a tough bite. And people are trying to go, where's that return on investment? I don't quite get all this. And frankly, it can be a tough sell. But if we combine energy efficiency and get the cost down, we can make solar very affordable. And that's why you'll see solar go mainstream and really pick up the pace. We'll be putting smaller systems per house, but we can sell a whole lot more houses, and the incentives will go a whole lot further to more roofs by just doing energy efficiency first. Yes?
It seems to me like we've lost the battle to the Chinese for solar panels. we've lost the
I
wind
would-
energy to the Europeans, and we're left holding the bag. The only thing left for us is water. So I would think that we should start thinking about that
I'm
resource.
glad you brought that up. We're gonna get to that, because water is very important. And that's in this presentation. But the solar, the Chinese solar, I've got German panels that I can compete with the Chinese prices. It's not totally true that the Chinese market's running away with it. I can get solar made from Germany, manufactured in the United States, $1.10, $1.20 a watt. These are hard costs. You're familiar with cost in solar. These are very good numbers. I can compete with the Chinese all day long. They like to make that mystique out there that they're cheaper and everything else, but it's not really true. It's because the industry prices have come down. Now here's a real bummer about the solar industry. The guys who are in the industry trying to make a living, they work on commissions. Well, 5 years ago when I was selling solar, I was getting $10, $11 a watt. Today, I'm lucky if I'm selling for $6 a watt. Well, what do you think that does to my 5% commission on a solar system? I'm having to sell twice as much kilowatts to make the same income that I made 5 years ago. It's a tough sell. It's really getting tough out there. So I actually feel for all the solar people out there trying to make a living on this. And I tell you, a lot of them are struggling.
Well, for the attorneys in the room, from a report I read, that the #1 sector that all the patents were filed in California last year to bring it back to the States were in the solar sector. I mean, filing all this new technology, getting the efficiency up, you know, California, the entrepreneurs and the scientists or whatever you want to call them are kind of leading that pack. So bringing the IP back here, even though they're going to export it to manufactured China, but it's not going to be back here.
Well, as I mentioned, we love solar. Solar's good, clean, quiet, low maintenance, safe, proven reliability. It's got a great track record. I think solar's a great thing. So I'm not here to badmouth the industry. I just want to keep it in the right perspective. Combining current incentives and recent financing, solar is available at $0 down and $1,000 cash back. This is like buying a car. Positive cash flow from day one. The banks are stepping up to the plate to make this happen. Increased property values from day one. And yet, it's still a tough sell when you put all those numbers up there, because people aren't addressing energy efficiency first. They're just looking at trying to put solar on there like a Band-Aid to fix the problem. Opportunities, 100 square miles of solar would take care of all of the energy that we use in the U.S. today. 100 square miles of solar. We wouldn't need any foreign oil, wouldn't need any foreign energy from anybody. 100 square miles.
How many square miles is Los Angeles County?
Well, it's a good point, but the power need to be evenly distributed. You couldn't put it all in one place in one desert and say, we're good. No, you're going to lose so much in the transmission trying to get it down the power line. That doesn't work. However, right at the bottom there, you see that the railroads own 2,800 square miles of land across the United States. There's our grid. We could easily put 100 square miles of solar along the railroad tracks. We could put a little bit more and make it for electric trains. Right? And we'd solve a lot of this real quickly using existing land, existing means. So homes are not just the only candidate. Commercial building is not the only candidate. There are other solutions out there. So I do embrace solar. I love solar, but we just got to keep it in the right perspective. Yes?
Yeah, can you just address the idea of, let's say, as a homeowner, you want to throw up some extra tiles up there to sell back your electricity to, I don't know how those numbers work at all.
Well, feedback tariffs are still in discussion by the utilities, and they have not given us the magic number yet that we're waiting for. The governor signed this bill last year and said, feed-in tariffs, going to make it law. That's great. But the utility companies haven't given us how much they're willing to pay us for that power. And if you come back to wholesale costs, doesn't really mean anything.
I can interject. I was just at a solar workshop, California Solar Initiative workshop this morning. You know, and so what they do is they take your last 12 months of history.
Yep.
That's what they base it off of.
So what you pay, what you paid per kilowatt, you can sell it back to them at that price?
No,
No.
they're not going to sell you retail price.
They buy wholesale.
They'll buy it at wholesale, but they're not going to pay you retail.
50,000 kilowatt hours. I mean, that's small, but whatever. 50,000 kilowatt hours last year for the last 12 months. When you come in and get your rebate and all your systems and all the net metering going back, so that's what they set that off. Now, if you come in and use 60,000 kilowatt hours, you're gonna pay for that additional 10,000 kilowatt hours from Edison or whoever your utility is. However, if you come in and you use 20,000 and you produce 30,000, they have to pay you off of that net metering balance. But their whole goal is, they just want you to produce what you use. That's it.
Yeah.
That's
Another way of wording what he just said is, to get the rebates and incentives to make solar more affordable, you can't exceed historical usage. Otherwise, they won't give you any rebates and incentives. You want to build a 40 kilowatt solar farm or 40 megawatt solar farm, they're going to go, hey, go for it.
Right.
They're not going to give you any money.
Yeah,
But if you want to get these rebates and incentives, then you have to stick within historical usage. Well, if you're sticking with historical usage, how are you going to be giving feed-in tariffs or providing any extra power? But I figured this one out.
You lie?
You come in and you do the solar system based on historical usage and kind of have a blind eye to the energy efficiency. And maximize your rebates and incentives, and then come back on the backside, do the retrofit. Now you stayed within historical usage, and you've now increased a revenue stream. So if they give us a good number on the return on what they'll pay us for that power, it's potentially a good investment. But we don't know yet. And I don't want to go there and start telling people to do this until I find out what that number is for the utilities. What are they going to pay us for that power? That's the unknown.
Thanks.
But it's a great question, feed-in tariffs. By the way, feed-in tariffs is why solar went so strong in Europe and a lot of other countries. And yes, Wally.
To back up, to answer your question, I really got to get out more often. I'm such a nerd. I happen to know acreage in LA County, miles 2,812, but you could think of that 100 miles that would drive America as if you blanketed the San Fernando Valley, with all due respect to your house, if you leveled it and blanketed the San Fernando Valley with solar panels. Granted, as Wayne says, you can't do it in one spot because of the grid, but if you could, that would run buildings in America, which is pretty amazing. So I think we should only knock down Reseda.
It's okay, I live in Encina.
Okay, so I've come back to the numbers we looked at earlier. We now know that we don't need more power plants. You hear about the Edison wants to build peaker power plants. In fact, they're upping our utility bills. They're going to raise $1 billion on us over the next 3 years, so they can build more power plants. They're going to build one right here in Oxnard, right? We know that they don't need it because homes can certainly consume 42% of the energy, and if we can cut that energy by 40 to 70%, that represents a 17 to 30% energy reduction in the total usage in the state. That's a lot more affordable and a better return on investment than any peaker plant, because peaker plants don't have return on investment except to the power company.
So if they raised that money, or a third of that money, and used it towards making people's houses efficient, they'd never have to build another plant for, well, for a long period of time anyway.
Exactly. Solar.
Population.
And it would cost them a third as much, maybe half as much.
Plus they're buying natural gas the cheapest they've ever been to fire the turbines. You ought to be giving us a lower rate instead of a higher one, which is another interesting perspective.
Are there any mass
That's called
programs
publicly traded.
to publicize these rebates and to do?
Energy Upgrade California is one program, PACE is another program. I mean, I've kind of named several of these programs, and there's a few more out there. Some of them are local to jurisdiction, some of them are more broader
But it still
based.
requires the individual homeowner to go do something, right?
Yeah.
It's not.
Yeah.
No, there's some for businesses, and there's some for homeowners.
Right.
And they may never meet.
You got to get Britney Spears behind one of these programs.
Really?
Push it out there.
So this is a lot of numbers, but this is why I wanted to come back to these numbers, to give you a perspective of what does it mean that we can save this much power when Edison's trying to tell everybody, hey, we got to have peaker power plants, and they're trying to make the case. Did you know that the city of Oxnard spent $100,000 trying to fight Edison on this?
Yeah, it's in the paper.
And lost it.
Yeah.
$100,000 to Edison. Edison's determined they're going to get their peaker power plants. And they know this information.
What's the peaker power plant?
These are power plants that take care of the peak loads. You know, have brownouts, you know, the peak loads during the
It's
day.
like turbocharging 99% of the time, and then the 1% of the time that you need some sort of super burst of energy in the hottest day of the year in the region, it goes on.
You know, even that, if you look at the numbers, we had a huge heat wave in August. Do you remember that?
Yeah.
There was still about a 25% capacity excess. That was for all of California. I don't know how it broke down by the utilities. There's still 25% available during that peak time frame.
Mm-hmm.
So it makes you wonder, question even that aspect. Where's the data to say they really need it to cover that peak?
They probably got that from Enron.
Yeah.
Well, yeah, that's, you know, that's the old Arthur Anderson motto of they've got very impressive presentations that are all based on figures never lie, but liars can figure. Some presentations with PowerPoints that knock your socks off when it comes to the numbers.
So I know we're talking about lowering energy costs, but there is something more important in energy conservation. Thank you. Water.
Oh, boy. That's
Water
a pet peeve.
is more important than energy, because we can't live without water, and we can't live without energy. We used to. It's just a fact of life.
Well, electricity anyway.
Water is going to become the big dilemma. And I've done a lot of studies on this. There's a great documentary out by an organization called arewerunningdry.org. They put out a film called the organization's called runningdry.org, and they have a film called Are We Running Dry? Really informative issue. And this documentary showed me the numbers that I was looking for. Because the big argument against desalinating ocean water to make fresh drinking water was always the cost of the energy. Right? What they just realized is that the amount of money they're spending to pump water from the Delta and from the Colorado River to Southern California has reached the same per gallon price as desalinating water. It's no longer an argument. It doesn't hold water, pardon the expression. Basically, it's now cost effective for us to really seriously look at desalinating ocean water. And if we took California off the Colorado and the Delta, Southern California off the Delta and the Colorado, we would benefit 6 other states where they're really desperately needing water. The Colorado River used to be...
How about if we take them off the Colorado? They can benefit us.
But the Colorado River used to make it to the Sea of Cortez.
No, it doesn't.
No.
Doesn't even make it.
It hasn't done it for a long time.
Right.
Yeah.
But why is that? Because these 6 states that are in that area are the fastest growing states in the United States right now in population growth. They're building homes there, slam them in, and they have no projections of where they're going to get this water from.
Well, they got this desal plant in Yuma. Is that, they can recommission that sucker, right?
Yeah, well, they need a
Santa
whole...
Barbara has one that's never been fired up.
Yep.
Really?
Yeah, it's amazing. It's like a 12 or 13-year-old plant. I think it's older than that. About mid-90s, there was a big drought, and off a bond issue, the city of Santa Barbara, I forget what the number was, but spent tens of millions of dollars to build a desal plant, because, you know, everyone wants their 4 acres nicely landscaped in Montecito. And they never fired it up by the time the plant got built, and the drought went away. And it's now been sitting non-functional for so long, it would be cheaper to build a new one than refire this one. Or not even refire it up, turn it on for the first time.
Wow. And
Yeah.
interesting part of that story is the same year they had the plant finished was the same year that they adopted state water from the occupant. Same year.
You know, another part of this water thing that's amazing is Wayne's been given this great presentation on power, and we'll now have a little quiz of the electricity consumed in California. Does anyone want to guess what percentage of it just moves water around?
About 45%.
28. 28's the number. Good guess, though.
But
Yeah.
give me the other number, Wally. How much is it to move wastewater?
Another 6. So if we could all number 2 a little less, we can turn that number down.
Those are numbers of mine, 34%.
So what is that? Eat less bran?
Exactly. Yeah, shorter showers and eat less bran, and we could bring that 34 down.
But those two numbers combined represents a third of all the power consumed in California.
Yeah, is that amazing?
It's just pushing water around.
Yeah, yeah.
No, water's heavy.
Yeah, in or out of you is the case maybe.
And yet we have the, I have to talk about this real quick, but the LA River, $1 billion a year LA County spends to bring water to LA, $1 billion a year. And they turn around and spend hundreds of millions of dollars every year to do what? Divert stormwater out to the ocean.
Mm-hmm.
Hello, what's wrong with this picture?
That was my next question.
You know, it's like we've got this resource, that's our drinking water. And by the way, I don't know, does anybody know what the percentage of water on the earth is actually drinkable?
About 1%.
Yeah, it's really a small minute part. So does it make any sense that we're dumping all this fresh drinking water out to the ocean?
Well,
It doesn't need it?
Let's talk a little bit about rainwater capture.
Yes.
Yeah.
We get on average here in LA about 14 inches of rain yearly, which 14 inches is an acre foot. Is an acre. So that's a lot of water.
It is.
But the point is, if you required every building to have a rainwater capture system, now you could use that for gray water, but you probably wouldn't want to drink it.
You could use it for showers, you could use it for flushing toilets, you could use it for...
Yeah, you double plumb your house. You could run your showers. You could run your laundry, and you could run your toilets off of it. But you don't want to drink it unless it's been cleaned, particularly because it comes off your roof, and the roof is covered in all kinds of pollutants and particulates. But if you could take that water and save that water, what would that mean? Would we need to build a desal plant?
No, it's a great question, and you notice that I have a figure here, 28,000 gallons in December.
Yeah.
I'm going to tell you what this is. I have, on my property, I have my house, and then I have a shop out back, but my combined roof space altogether, I did the math in December of this past year. Not the whole winter, just 1 month. And I could have collected 28,000 gallons on my own little half-acre property. And I did the math further on that. I took it out 365 days a year, that's 81 gallons a day. I don't use that much water. I've never used that much water. So what did I learn from this? We don't have a water shortage problem. We have a
The average family uses more than that.
Oh, yeah, just to irrigate the lawn.
That's I would need a 20, that's the why I don't have it, because I have to have a 28,000 gallons of capacity to store that water.
A pool.
And by the way, water storage costs about $1 a gallon. So if I bought 28,000 gallon tank, I'm gonna spend $28,000 getting that tank, and then I gotta put it in the ground.
Now, can I convert my swimming pool to a cistern?
I'm sorry, I didn't catch all that. Well, go ahead.
Can I convert my swimming pool to a
What a
cistern?
great question. No, not as a joke. What a great question. And the answer is yes.
It can be done. And you're,
I was gonna say, typical service station today has about 30,000 gallons of capacity in tankage. So there's what you're looking at, if you had 3 10,000 gallon tanks.
right, yep. That's just my property, but my point is, we have the water. And 14 inches a year is enough. Brad Lancaster wrote a book. Brad Lancaster lives in New Mexico. He gets 12 inches a year in New Mexico. He can harvest 100,000 gallons
for New
a
Mexico.
year on his property in New Mexico. 100,000 gallons of water. He has so much water in his property, he's growing edible gardens and having people come over and enjoy the gardens on his property. Yes.
Last year, my partner and I wrote a 20-year plan for Santa Fe County in New Mexico. And we wrote a land development code. And one of the things we required is that every building, commercial or residential, under 2,500 feet had to use at least rain barrels. Anything above 2,500 feet, you had to build it with a cistern.
How big a cistern?
Whatever's required. We're not writing a building code. We're not that kind of. We're lawyers, not construction.
And rainwater's great. Rainwater's great, but let's not forget about gray water. Gray water systems are now approved in California. They have a proven design. We can do these.
And they're cheap.
Yeah, and you can basically use your washing machine water and use that to be irrigating your yard. So if you were harvesting your rainwater and doing gray water, you would see that your water consumption would drop drastically. So there's conservation.
Even if you just watered your, even if you used it just outside and didn't have to run the plumbing into your house, it would be a tremendous amount of savings.
Yeah.
I mean, you go walk, you drive around LA, you see it, it's raining outside, people's sprinklers are on. It's unbelievable.
All the time.
Yeah.
All the time.
Right. Sponge basins, real quick. Sponge basins is where you have divots in the ground. Usually, if you had a tree or a bush or something like that, you have a divot in the ground, but you fill it back, the divot, the shallowness, with mulch. So the ground looks level, you walk across it, it feels level. But what you really have are bowls that capture water. And they soak water up like a sponge. When it rains, just right into these bowls and hold the water, but they water your plants and your trees much more deeply and thoroughly than if the water just runs off the surface. If you watch rainwater typically on a yard, most of it's running off to the street, hitting the curb, going to the creek, and then out to the ocean.
Well, that's because of those sprinklers are watering the sidewalks instead of the
Also,
grass.
we design our roads and our ditches and our
please.
yards so that everything goes to the curb. There's a lot of change in the green building cycles where they're cutting the
Culverts.
sections of the curb away.
You don't need
and
curbs.
creating sponge basins back into yards to get the water off the streets, back into the yards and replenish the water tables.
Mhm.
This is going on in a lot of places. Because that water is a resource. We should not allow it to be running back out to the ocean.
And you can have permeable driveways
Yep.
and permeable sidewalks. You don't have to have concrete.
So when we talk about money, LA County can figure out how to tap into that
Apparently.
$1 billion a year.
Shun the
They could get
unbelievable.
a better management on the water. You know, and not to mention the $1 billion a year they bring water in, but the other hundreds of millions a year they're spending to pump water out, to divert it out to the ocean. And by the way, I don't know if you know this, but 10,000 pounds of plastic goes out with that water every year into the ocean.
What is the level of our water table now?
What water table?
Where? You know, I mean, some places I'm here, it's 300 feet below where it used to be. I mean, it's drastic. A lot of it has to do with the density and population in a given territory, jurisdiction.
The reason I asked the question, I remember reading in Oxnard, the water table was dropping really low because we were consuming too much water, and it had dropped below the water table for the ocean.
The salinity level.
And the ocean was coming in and
Probably
basically
salt
bringing
water.
the salt with it.
Sure.
And
And it
ruining
destroys your
the
aquifer.
agriculture.
Yeah.
That's why I asked the question.
Yeah.
What's going on there? Does anybody know?
That's a case that's going on not just there, but all around the world.
All over.
The island nations are suffering the worst. There's a whole Indonesian island, 11,000 people that had to go to New Zealand to seek refuge. They lost their fresh water. Every bit of their fresh water got contaminated by salt water because of what you just
Turned into a
described.
desert. You're
Right.
done.
Tavaru, the island, they're now experiencing the same thing. They're having problems with their waters becoming contaminated, and they got some desalination plants going. They're trying to figure out how to exist. The island nations are going to be the first ones to suffer, and they'll see it before any of the rest of us are. By the way, if you go to island nations, you'll notice they're one of the first ones to do rainwater harvesting. They get it. They understand it.
But they are doing aquifer restoration on Camarillo. Because
Oh,
they're
yeah.
capturing a lot of rainwater.
Camarillo,
and
Somas,
Yeah.
there's lots of places where they're doing water replenishment, water conservation to get
Right.
the water back into the tables.
Yeah.
In my opinion, it's a good step in the right direction. It's still got a ways to go
Right.
before they get to the numbers we need to get to.
One of the
to
things
stop
we,
some of that invasion from Oxnard.
one of the things we were doing in Santa Fe is, they were changing their whole model. Up until now, their model has been, if you could drop a well, you can build. And that was literally, you could build anything you damn well pleased if you could drop a well and supply yourself with water. Now they're getting away from that because they've recognized that their water table is dropping faster than it's being replenished. And what they've done is they're trying to go to surface waters. They're trying to use the Rio Grande. They're changing the whole model for so that they can use their aquifers as their last resort water. They want to recharge them or let them recharge naturally, and they want to stop dropping wells. And they're making it now that you can't have water, you can't build anywhere you want. We're changing, the 20-year plan created areas where there's going to be growth, areas where we're going to grow in the next 10 years, and areas where we're never going to grow. And we're not going to allow you to still go out there and and build supermarkets and housing tracts.
Sure.
And then drop a well. It's just,
Now,
it's no longer viable.
It's understanding sustainability. What is sustainable? And you're right on track. It has to be planned. It has to be thought out before we just go wildly developing open territories. Yes?
There's a real battle going on now, bringing that Trans-Canada pipeline through the United States, right across the biggest aquifer we
we
have.
need
here.
energy.
Yeah.
By the time they
That'll
get
be
that done, we'll be
interesting.
using something else. It'll be like that plant in Santa Barbara.
Little news about natural gas. There's two pipelines that come to California. One is Texas, one is Canada. Canada's already announced that they've got growth up there and they need to cut back on how much they're supplying California with that pipeline because they need it for their growth. Texas is going, yippee. They get to bring their rates up. And guess what? California's at the end of both of those pipelines. All the consumers on the same pipeline before us pay less than we do. We're at the end of the line, right? Canada cuts back, Texas is going to bring the rates up, and natural gas is going to start just climbing. And yet, you'll still have a lot of people out there who are trying to think that natural gas is going to be the savior. It's a limited resource. And just on that note, we were talking about healthy homes earlier. How many people automatically turn on their vent hood when they turn on their stove? Wow, no. One, okay. You know that natural gas emits formaldehyde emissions and toxic nitrous oxide emissions into your home? They're invisible.
Well, sure, it's carbon monoxide.
Right.
It's just burning gas. What do you
And if
think?
you're not turning that vent hood on when you're running the stove, it's going to your home. It's contaminating your airspace. In my mind, vent hood should be automatic. You hit that igniter, the vent hood should come on.
I've got a big stove too.
Yeah.
135,000 BTU.
So, wrapping up here.
And I've got a jet engine for for a ventilator.
Stand up when it kicks on.
Oh man, this thing spools up like a Boeing 757.
I want to give credit where credit's due. And as this says, I have been blessed with the presence of many talented, inspiring people who work hard behind the scenes, like my friend Wally here. Yet there are too many to name, and in this network of individuals who have motivated me to keep learning more and to do this, I remain a student of energy to this day. I'm a teacher and I'm an instructor, but I remain a student because I'm constantly trying to keep up with all of this information and how it all keeps changing. And I think if you're not staying in that mode of constant learning, this thing's going to get past us. We have to just keep learning more and learning how to do better. U.S. Green Building Council, the C4 is the local California Central Coast chapter, which Wally and I both serve on the board of directors for. The VCCA is the Ventura County Contractors Association. For those of you who don't know, this is the oldest and largest nonprofit to the county of Ventura. They date back to 1945, I believe. And they have about 500 plus companies as membership. And I've been on board 11 years now. I was able to start the Green Building Committee, founded it, and I chair it to this day. I started in 2003. So I've been teaching the contractors this many years for green building. My big reward, or the confirmation, if you will, was when in January of this year, green building became mandatory. And all the naysayers suddenly looked at me and went, oh, what do we do? And it's like, it was really just seeing it come back, all the work that we've been doing behind the scenes, volunteering, trying to get this message out, is finally catching on to the point that California says, okay, it's now mandatory. You're going to start doing this.
But keep in mind that code is a floor, not a ceiling.
Correct. It's a stepping stone in the right direction, and we expect to see every year that chapter to get more addendums and more addendums as time goes on. But I'm just glad to see that we're the first state in the United States to make green building mandatory. All the builders now are coming to us and going, all right, how do I do this? So Wally and I are teaching Cal Green classes once a month in Ventura for free. We make it available. Contractors come in, have breakfast, and they just pay for their breakfast and learn all about Cal Green. And we try to keep it down to, we're doing four sessions. So in 4 months, you can learn all of Cal Green. Or you can go pay the fee of sit through one of these half-day classes and see how much you can absorb. Trust me, the breakfast meetings go over really well because it's in, pardon the expression, bite-sized portions that you can absorb. PH Living.
Wow.
This is, Tom, do you know about PH Living?
I've never heard of it.
PH Living is formerly Ecotech.
Oh, good for that.
Yep.
Good, good.
This is, PH Living is balance, pH balance in homes, finding that healthy balance. Thank you.
Wayne, back up a little.
Okay.
You're missing something.
Oh, what did I say?
Wayne's missing a
Oh,
plug
the
for
Ojai
Ojai Valley Green, and I gotta say, because Wayne's so modest, Wayne only serves on about 92 green building committees around the county.
He's a
And
slacker.
because he's such a deadbeat and slacker in the sustainable building community, it takes his wife to be the executive director of the Ojai Valley Green Coalition to pick up the slack for the family.
Well, that explains why he's not
Wayne is
mentioning
such a deadbeat in these sort of things.
A lot of people ask me why I do so much, and I go, have you met my wife?
Wayne and his wife see each other on a milk carton occasionally. They do a lot of good, but they kind of come and go in the night on the way to meetings.
So, yeah, the Ojai Valley Green Coalition, and I do live at Lake Casitas, right there in the Ojai Valley. By the way, those of you who don't know, we've been talking about water. Ojai Valley is the only valley in all of Southern California that has its own water. 31 water districts for 28,000 people.
Why do they need 31 water districts?
Oh, that's a whole story.
Yeah.
But it's interesting what's going on with all of that. But yet, it's the only valley that's not connected to the state water program in all of Southern California.
So Wayne, let's make it practical for some of us in the room. So most of us are probably owning homes. What should we go and do in the near future to conserve energy or make changes?
Get an
Well,
envelope
I've really
test.
been pumping the energy audits, the analysis, getting the hard numbers. Because before you invest in anything else, you want that report card. In my mind, it's only a matter of time before the building inspectors are required to be able to do this testing, because every home that's sold, the homeowner deserves to know what the real operating cost of that home is. And the only way you're going to get that is to have this testing done to verify what the utilities are costing you and what can be fixed.
Doesn't Texas do this already?
Not that I know of, if they did, I'd be impressed.
The city of Austin does,
Austin,
as an
I've known about this
individual
for years.
municipality.
That's where my family is.
Yeah, the state does
It's
not.
part of your purchase.
So what's the cost? What's the cost?
Yeah, what's the cost for typical, either bid per square foot or for a typical home?
We do energy audits in 3 levels. Capacity starts at about $500 to $800 for any home up to about 3,000 square feet. Larger homes, price can go up. If there's multiple HVAC systems, the price can go up. If there's multiple zonings within the building, the price is going to go up. But these are to find out what it's going to cost you. Now, the rebates that we talked about earlier, incentives, they don't help you on the testing part, but they help you on the retrofit, the work that it's going to cost. Because once you have those hard numbers, now it's, okay, here's what you need to do, and it gives you a priority or a pecking order, if you will. What do you want to do first? And without the testing, I couldn't tell you what you should start with. I got to have the test. I really believe that the test is the way to find out.
Let's talk about a couple of basic things. So how often should we inspect our HVAC systems? Once every 5 years, every 10 years, when we sell the house?
Well, you should have it audited, tested, and fixed, and see where your numbers come in at after it's fixed. And then when you start seeing your things start getting different, you know, the bills going up, I'd have it checked again. Hey, come out, check my HVAC.
You need a baseline.
Think of the energy audit